assigned for projectile motion. Number 17, this unit of measure is meters, so the first thing you need to do is identify the formula to use. So here you'll be using the formula with 4.9. The initial speed or the initial velocity is 24.5 meters per second, and you're asked to determine when it's 19.6 meters high. So the h of the equation gets replaced with 19.6, and the r gets replaced with 24.5. And t remains as your variable in the equation for number 17. And then you arrange it in a factorable order, and these are all set up to work out nicely. If you factor out a 4.9 from each term, you can see that it turns into a really simple polynomial. And then you're simply left to factor what's inside. So you're looking for factors of 4 that sum to 5, and the 5 is negative, 4 is positive. So that means both of your binomial factors have the negative constant. And when you solve each binomial factor, t is 4, t is also 1. So what that tells you visually, the height of 19.6, the ball went through that height 2 times, first at the 1 second mark and then again at the 4 second mark. And that's what you would need to do to answer this. And then the book gave you the hint that there were 2 answers, and you did get 2 answers for this. Okay, number 19, a baseball problem. A batter hits a baseball upward with an initial speed of 120 feet per second. So the formula that you would use, formula measuring feet, and the initial speed is 120, and you're to assume in this problem that the height is 0, that the ball leaves the ground and that the catcher's catching it back on the ground again. And they don't explicitly say that, but that is the way that that's what you need to assume in order to solve this problem. So h becomes 0, r becomes 120, and once again t remains as the variable in the problem. And in this problem, 8 is the common factor. So if I remove an 8t, what remains is this, 15 minus 2t. So the first root, the first time value, if 8t equals 0, then time itself, or the variable t, has a value of 0. And then the second binomial, 15 minus t, solving that for 0, t would be 15 over 2, or 7.5 seconds. So assuming that the ball leaves the ground and then comes back to the ground, when you have a height of 0 on both sides, time is 0 before it takes off, and then time is 7.5 when it lands back on the ground. Number 20 is slightly different. Mitch tosses an apple to his friend who's standing on a balcony 40 feet above him. His initial speed, the initial speed that he tosses, 56 feet per second. And she misses the apple on the way up, but she catches it on the way back down. So the question asks, how long was the apple in the air? So a little bit of thinking involved here with this problem. First of all, we're in a feet situation, so the equation that you would use is the equation with the 16. And she is on a balcony 40 feet above the ground. So let's let the height be 40, and then the rate becomes 56. So let's set up the equation, then let's look at a sketch so we can understand what's happening. So I'm going to rearrange this into a factorable form. and then removing an 8, leaving behind and assuming that everyone can factor. Let me go ahead and give you the factored pieces, and then let's analyze visually what's happening so that we can make sense out of this. So my 2 times t is 5/2 or 2.5 seconds, and t is 1 second. So what's happening? You have someone standing on the ground, and they're tossing this object up to a height of 40 feet. So my height is 40 feet. The object hits the 40 feet mark 1 second, at a time of 1 second, and then again at a time of 2.5 seconds. And the question asks, how long is the apple in the air? Well, when you think about what's happened, the apple leaves the ground, and on the way up, the friend misses the apple, so the apple continues on its trajectory, and then she catches it on the way back down. So the apple's been in the air for 1 second the first time she sees it, and then she catches it at the 2.5 second mark. So that means the apple is in the air for a total of 3.5 seconds before she catches it. So I think that the visual representation going along with the algebra helps you to understand exactly what it is you're solving for. Number 21 is very similar, and this is a flare fired upward in the air with an initial speed in meters per second. So your formula is the formula with the 4.9. And you've got a balloonist at a height of 1,960 meters. So the h in your equation becomes 1960, and then r gets replaced with 245. So as always, arrange this into a factorable form. And in this problem, 4.9 is a factor. So when you remove 4.9, what remains is something pretty easy to work with. And this is simple to factor as well. I need factors of 400 that sum to 50. So that would be 40 and 10. So that means my 2 answers in time, 40 seconds and 10 seconds. Now let's do a little sketch to figure out what we're dealing with here. So we've got a balloonist, and the balloon is at a height 1,960 meters in the air. And this flare passes that height 2 times. It passes through this height at the 10-second mark, and then again at the 40-second mark. The balloonist sees the flare when it passes through its height the first time. And the question says, how long after this will the flare pass the balloonist again on the way down? So if it passed through at the 10-second mark and it continues on, and then at the 40-second mark it passes the balloonist again, that would be 30 seconds later would be the correct answer to this question. 30 seconds later is when the balloonist would see the flare again. Number 22 is slightly different because the ball is not thrown from the ground. The ball is thrown from a tower above the ground. But the problem gives you all of the information you need in order to solve this. So we're in a meters problem. So the formula that we would need would be the formula with the 4.9. And here, so let's do a little visual so we can figure out what's happening. 98 feet above the ground, this object is tossed. It's a ball that's tossed. And then it comes back down to the ground. So we start at a height of 98 feet. And the way the problem accounts for the fact that the ball was not on the ground and returning back to the ground, they tell you to let the ground have a height of negative 98. So my ground in this problem is represented by negative 98. And that's how they account for the fact that the object left from a height above the ground, but it returned back to the ground. And the problem asks us to determine how much later will the ball hit the ground. So if we replace the h in our equation with -98, that represents the ground height in this particular problem. And let's see, they're telling us 39.2 meters per second, so the r becomes 39.2. So plug in your numbers, rearrange it so that it's factorable. And these are all set up to work out nicely. When you remove 4.9, you have something left behind that's really simple to work with. And here you have alternating signs in your binomial factors. The root that we can use is the root of +10. T is +10. So to answer the question, when will the ball hit the ground again? How much later will it hit the ground? It would be 10 seconds later. In 10 seconds, the ball is back on the ground. That would be your answer to this question. And I think that the other questions are really straightforward and simple, combined with the problems that we did in class. And if you watched this video and understood the explanations, you should be able to get through all of the other problems.